Yeah, back then, I remember 2017, I went to DEF CON in Cancun, and there one person told me, like, why do people even go inside of talks? Like, they're all recorded, you can watch them later on, like the actual action happens outside when you meet the people. I kind of agree, so thank you so much that you anyways come to watch my talk. Yeah, let's start, let's get into it. How does it work? Like this. So who knows what the graph is? All right, okay. So real quick, so that's the graph, you know, like the blockchain is a big mess of different stuff and it just magically puts it in order. Or we can also look a little bit more at the architecture that I know from Melonport back in the days, that we have the front end on top, decentralized, and then a data layer, which is the graph, and then the smart contracts and the blockchain. So it enables that access to blockchain data, or as I said, the data layer of Web3. The graph is not only just a technology, it's also a decentralized network. As of now, I think this morning, there are 239 indexes, independent indexes across the world that index subgraphs. There are 120,000 and more delegators, curators, and then the subgraphs, the one topic that we go a little bit into it. So it's a decentralized network of data, if you want. As of today, there are 3.49 million GRT in query fees already processed through the network. So you see it's actually one of those decentralized networks that work, and it's not just promises. We end up with truly decentralized data. But the other concept is subgraphs. Who's familiar with subgraphs, the concept? A little bit less. All right, so a subgraph, as engineers, we can simply think about them as database schemas. So like, we have that mess of different data that's on the blockchains, and we want to kind of make sense out of it, so we design a database schema, and then some logic how to fill that database schema according to what happens on-chain. So as I said, like the chain, we all share the same block space, all the protocols share the same block space, and if you want to make sense out of it, usually we're not interested in its entirety, but like very specific in the certain contracts that are there. And then subgraphs, basically, you can think of like this logical unit that kind of defines a database that is very specific to one particular use case. So when you, for example, look at the subgraphs that Messari is writing, they have like for each protocol the subgraphs that are tracking them, storing them in a way that then they can, in the end, create their protocol matrix on top of it. So then when we talk about read-oriented rollups, then we need to maybe think about the subgraph data flow. Do I have a laser pointer here? Ah, nice. So everything starts with the blockchain. So on the blockchains, we have all that data that kind of streams, as I said, like into these mappings. This is written in assembly script. Or like in the newer technologies for substreams, it could also be Rust. In the end, like it compiles down to WebAssembly. Then it goes to a store. It can be read from the store if needed, but in the end, the consumer can just query it. The magic happens actually here in these mappings, because assembly script and also Rust are so-called turing-complete smart contract, Turing-complete languages, so we can actually code whatever we want inside of that data pipeline. So, for example, there was a team that actually wrote the synthesizer into a subgraph that kind of gets block data and starts to generate music out of it. But we can also think about maybe some CK prover that run off-chain inside of the subgraphs and then can funnel back the data, but we go in that later on. So that's a cool thing. So I want to emphasize it's Turing-complete. We can offload a lot of computation from chain into subgraphs to make sense. So there was this idea that came up, actually it's a while ago, right, 2021, about like, hey, we can just like build a blockchain into the graph protocol by itself that inherits the security of Ethereum, kind of this idea. So then, okay, how would that look like? And it's basically very simple, just a smart contract. We call it the data edge. You can find that also on the Graphs forum. That just has a fallback function that basically does nothing. But the cool thing is, when we call that function, we can provide any call data into it, and that call data is stored on chain, right? And then we can write a subgraph that watches that data edge contract and gets that data in. And maybe we can come up with something like, there is an instruction set, there is some logic going on, a little bit similar as Bitcoin people try to have their ordinals that have their logic that might or might not be applied. But yeah, that's the data edge. So in a very extreme way, then the blockchain is just like the data storage that triggers then all that logic computation in subgraphs later on. So what's happening is that logic can move from the blockchain to the mappings to reduce the load that we have on-chain, if needed. Another very interesting component that could come into play is so-called off-chain data. So far we looked at about on-chain data, which is kind of like, yeah, it's cool, we can maybe extract some stuff and do more with it, but we can even bring off-chain data into the mix, which makes it more interesting. So when I talk about off-chain data, what would be off-chain data? So for example, it could be empty seats for airlines. Airlines want to have monetize that more, want to kind of publish that data a little bit more, or we have hotel beds for hotels that they want to publish what's going on there, even like weather stations. So we can think about maybe like a decentralized network of weather stations that all has some off-chain data that we then want to bring back on-chain, or traditional or like not traditional, it's kind of like server data, like requests to a server or like quality of service, response times, and so on. So this is usually on-chain, off-chain. And the graph could be used with subgraphs to just publish them. I'll just show how that would go. So basically, the trick here is to have it on IPFS and Arweave, and subgraphs can then be triggered on-chain to then start to download that stuff from IPFS or Arweave, and then still go into the maps and store it in the same store. That's possible today already. So like for the off-chain data that we had before, the graph could be, or subgraphs could be and can be actually, the people are doing this, a way to publish data and make it accessible, because like data access in the graph network is already made. There are the indexes that store it, there are the gateways that give access to it, that they care about billing. So that whole hassle of, oh, I have that data, but I don't want to make it public because then I need to have an API, and the API that needs to have like access control, and that access control is complicated, and maybe I want to monetize it, and we don't have a credit. It all could also be offloaded to the graph. And yeah, it's simply by just emitting a hash of an IPFS file or an Arweave transaction, and then download it and store it. That actually is in use. So, for example, for the gateways on the graph network, that's what we do. Is there's a quality of service oracle, so to say. So whenever someone accesses the graph network, then it goes through one of the gateways. The gateways, then they send these logs. Some of them, now they don't need to necessarily, and they go into the Red Panda, materialize the EB, there is a cron job, and then like regularly there will be the whole access logs, so to say, like which subgraph was accessed, what was the query, which index was selected, how long did it take for the indexes to resolve that query, is then uploaded to IPFS, I think every 5 minutes. That IPFS hash is then put on Gnosis chain, and then there's a subgraph that indexes that data again and then creates that quality of service subgraph. So we can now go to that subgraph. Yeah, I cannot do live coding here, but we can now go to that subgraph and start to find out which index is the most performant, or like which subgraph is the most queried one, and so on and so forth. It's all there. It's very cool, and that's basically off-chain data. That could, like every other company, even like not a Web3 company, could start to publish data like this and have it accessible. But the magic comes when you put that together. So I kind of hinted quickly before. Imagine like we have like this decentralized network of weather stations that helps us to have like an oracle that says like, did it rain or did it not rain for my on-chain insurance for the, I don't know, Zurich Open Air or whatsoever. how would that work? How can then a smart contract know if it rained or not without like needing to trust maybe Meteo Schweiz or whatever? But then we can think about like there are like thousands of weather stations that are just uploading the weather data that they see into IPFS and then anchor it down on chain and say like that's what I saw. Then we can more or less have like a more trusted image about what's going on. Nice. That's all kind of like around using what's already there with the graph network. Like so, as I said, we have the indexers, we have subgraphs. Indexers have stake that secures the network. We can work like this. This is out there. And then we are back on chain. So now we have all that on-chain data. We talked about server access logs, quality of service logs, and also decentralized weather oracles. But when you want to bring it back on chain, that's the thing. Like with a decentralized weather oracle, we also want to have like this. There's this Boolean thing of like, do we need to pay out the insurance sum or not? Like, and that's where oracles come back into play. So I have like there are two examples, like Gelato, for example, with the Gelato Web3 functions. They can read from a subgraph on the decentralized graph network and then put it back on chain and then say like, okay, actually it rained. So you can have, so you need to pay out. Yes, that kind of closes the loop. The cool thing is, all that information, we go later into that also, that is not just like someone has said, but there is some economic proof on top of it. I think it's the last slide. So just to recap quickly, so why am I talking about subgraphs as roll-ups? Because basically what happens in roll-ups is like we have the block, we have the L1, and then the state goes up, the state will be changed, and then the changed state goes down, and so on and so forth. So that's kind of like how we can think about the roll-up. And now when we go to the graph, it's read-oriented rollups. It's like there's also state happening on L1 that goes to L2. There is some computation going on, and now if oracles, we can even bring it back on-chain. It's a little bit different. It's kind of like the focus is on reading and processing. Yeah, if that makes sense. Yeah, closing thoughts about the verifiability. Yeah, especially when we have oracles that bring stuff back on chain, it's like when we look at this, let's say, Gelato Web3 functions, like they can query any endpoint. But what we need is we want to know like, is it actually true? And so with the indexes on the graph network, the thing is that they have stake. So all the indexes on the graph network stake a good amount of GRT, some more, some less, and then whenever they respond to a query, they send a so-called indexer attestation back and say like, with my stake, say that's true. And if someone can prove them wrong, then can be slashed. So it's not just like something, it's actually, yeah, they prove with their stake. There's also more going on, like can we have more verifiable indexing, more verifiable queries? The indexers also start to talk to each other with gossip networks and so on to see if they see the same data. But in general, this is how it works. It works with that stake at the moment. Yeah, it was a bit a quick one, right? But as I said, like it's recorded, so you can still watch it, maybe relax at home. This is the link to my Twitter, if you want. And yeah, thank you so much for having me.